Good morning. We're so happy to have with us Jeff Rahman, Shana Hetherington, and Sina Flynn with us today from Little Architectural. And they're going to be sharing about architect and the engineering and the design of buildings. So I'm going to go ahead and turn it over to you, and thank you for being with us in our iWork Speaker Series.
Good morning, everyone. I hope you're doing well this quarantine morning. Although you all are probably experts at this compared to a lot of students. I'm going to go ahead and share my screen. I'm an architect with Little, and I have been working on K-12 schools for over 20 years. I graduated from Louisiana State University, go Tigers, and I have a 5-year degree in Bachelor of Architecture. In architecture, you can do degrees a couple different ways. One is a 4-year degree that's a Bachelor of Arts in Architecture. And then you go on to get your master's, which is an additional 2 years. Or some universities offer a 5-year Bachelor of Architecture degree, which is the route that I went. Is if you are pursuing something in architecture, after you get your degree, then you go through a process of getting licensed, and it's a series of, gosh, I think it's like 4 or 5 exams now that you take to get your license. So that's kind of the overview. Let me share my screen. Hopefully everyone can see. So Little is actually a really large firm. We have 5 national offices, and our practices are broken down into kind of these categories, and that means different types of building types. I personally focus on community type buildings, which are K-12 schools, college and university work, and civic type work like libraries, police stations, things like that. Retail, it is what you assume, shops, grocery stores, places that you go and purchase. Workplace are office buildings. Healthcare can be anything from hospitals to doctor's offices. And then we have a huge variety of consulting specialties that I will get into a little bit. I'll start off by saying with architecture, you don't have to be great at math, and you don't have to be the world's best artist either. Architecture is honestly about generating ideas, communicating those ideas, and working with a whole host of people. So on a project, the architect is just the one small part. Jeff's going to get into talking about engineering. But what we do is, we are kind of that communicator between all of the different disciplines, which can include civil engineers, structural engineers, mechanical, electrical, plumbing, landscape designers, graphic specialists. I know I'm missing things. Specification writers, which are a whole different thing. So there are a lot of different components that go into a building. And our job as an architect is to listen to our clients, understand what the problem is. Essentially, I always say we're problem solvers. That's what I do every day. I see the problem and I figure out the best solution for the client. And we do that through a process that is kind of this 5-step process. Vision, discover, create, execute, and evaluate. And with vision, the first thing that we do is really listening to our client and helping them understand what their overall goal is. So it's a lot of talking, it's a lot of listening, and really asking questions primarily. So from there, once we understand what their goal is, we do a lot of research. We look into different types of, and this particular project that I'm going to go over with you is a school for Charlotte Latin. It's a private school in Charlotte, North Carolina. And we worked with them to develop a master plan as well as an upper school building for them. And so we went through the vision session with them, which was this last slide, and kind of talked about, understood what their problems were. They were overcrowded. They wanted a building that was for their upper school students, and they really needed a front door to their campus. It's a large campus, and currently, or before this building, you didn't know where the front door was. So that was initially the overall problem. So we researched, we talk about, you know, environmental sustainable thinking. We go through and show images and get their feelings on these different images. These are different spaces for schools. Because it's a campus, landscape engineering was a huge component of this. It was an existing campus. It was a very tight site. And how to create, architecture or I should say building design in general isn't just about the building. It's about connections to buildings and how you experience, especially on a campus environment. We talk about different types of learning. So understanding our client and how they function on a daily basis, in this case, education. What are the trends? We research a lot on what are the trends for education. How are students learning differently? Like you all learn online, and ever since this, the COVID, everyone's learning online. And so there's a lot of discussion and a lot of research right now about how is that going to change the way that schools look in the future, and how, what you all do might become a new normal for a lot of students. So with Charlotte Latin, once we have the vision, we go into the discover phase, which is about that research and about learning who they are. This is their current campus, and so we evaluate a lot of things like how do pedestrians flow, where are points of security issues, where do cars come in and park, and how do people approach the building. So it's that type of combination of engineering and architecture together to figure out where the best place was to put this new upper school building. The brown buildings are their current buildings, and we were trying to propose new additions, which are the orange buildings, and how that would work on campus. Ultimately, after a good bit of time, we focused in on this location here because cars come in and they arrive on campus, and this would become the new front door. It would allow people to know where to go. It would also provide a sense of security for the rest of campus because visitors wouldn't be, roaming around campus trying to figure out where to go. Once we do that, architecture, and Sina will get into it in a little bit about computer modeling, but we start to look at things holistically and how the existing buildings work, how they look, how they feel, and really start to study how a new building would impact that. This is another study. As you can tell with architecture, a lot of our work is graphic. So you might not need to know how to draw, but you need to know how to communicate, and whether that, and a lot of people do it different ways, whether that's like you see on the screen here, which is more computer graphics, applied graphics. It can be sketching, it can be drawing, it can be computer animation, which I'll get into in a little bit. So there are a lot of different ways. Your goal as the architect is to do whatever you need to do in order to relay that idea, because if a client can't understand what your idea is, it's not going to go very far. So this is kind of the initial site plan here of the building. And sorry, I'm kind of going quickly. And then we get into planning. So from discovery, we go into create. And in that create phase, we start to begin to lay out spaces based on information that we've heard. We look at it with imagery, and that helps relay that idea again. This picture here was to help us explain to the client what the steps going from the first floor to the second floor might look like and feel. And you'll see how that ended up later on. But so we start to give imagery and how these spaces kind of work. How classrooms might function, and really this is how we put it in front of the client and get feedback. In this particular case, it's different than probably what you think of with a school, and that we have a lot of spaces where students and teachers can kind of break out from a traditional classroom space. Resource rooms, 1 and 2 person rooms where they might do distance learning there, and then places for students to kind of gather together. Part of that discover phase is also looking at what the existing buildings look like on campus. So again, it's a lot of research, but as we begin to design, we're looking at existing materials, be it brick or precast, how site pavers work with the arrival points, and that really influences the exterior of the architecture of the building. And that will go through a lot of different iterations. So this slide is not what that building ended up looking like, but I wanted to explain how we go through a lot of different iterations. Now this is actually built in the computer. It's a 3D model. This was straight from our Revit program, which Sina will get into a little bit. And then we add color to it so that it feels more lifelike. And we do that pretty early on. And this is what I mean with being an architect. You don't necessarily need to know how to draw. It's a lot of computer work nowadays. This was the connection back to campus and what that front door once looked like. These were the earlier kind of drawings. And then this is what it ended up looking like after it was built. So you can really see the transformation it can make, but the concept overall is still there. You have the connection to campus, you have the front door feel, and here you have that connection to the rest of campus and the front door. This was that front door arrival point and the steps I mentioned in that earlier picture of how students could flow to the second floor. And this is how it ended up, very similar to what you see in the computer. So again, it's coming up with that idea, relaying that idea, and actually building it. This was a interior student space at the top of the stairs. You can see going down to where that entry was, and they wanted kind of a collegiate feel for a student commons area. And this is how it ended up, which this is kind of a laptop bar, and there's some soft seating on the other side, and that's their guidance center. And these are the steps that go down to the first floor. And sometimes things change. So this is how we had the original student space, and this is how it ended up, which is a little bit smaller, but still, for us, it's very rewarding to see students using the space how we actually intended. Again, this is a Revit model of an earlier version of the school. We had steps that matched the interior steps on the exterior, so students could flow whether they were inside or outside. That was an early kind of iteration. This image is actually a computer animation, which was part of a video. We have a group in our office called Skyscraper, and they take our ideas and amplify them. They do a lot of web-based design for clients. They do animation. There is, computer kind of fundraising videos. There are a lot of different aspects. So this was an actual rendering, and then that's how it ended up. So as you can see, let me get back and forth. I joke sometimes because often you don't know if that's a photo or if it's a computer animation. This is computer and this is actual photo, which is amazing. So in summary, I guess I'm going a little fast, is that architecture is really the problem solver and communicator amongst all of the different aspects of design. And I encourage, if anybody is interested in pursuing a design career and you're not sure whether you want to do graphics design or interior design or even some aspects of engineering, I always say start out in architecture because it really, you have to know a little information about a lot of different things. And then we pull in the experts like the specific engineers, whether it be mechanical, electrical, structural, all the different, civil. We know a little bit and we bring in the experts. And so it's a good degree to kind of start in to see if that is the route you want to go. You can do a lot of different aspects with an architecture degree. I think, I haven't looked at the stats lately, but I know typically people who graduate with an architecture degree, only about 50% end up doing traditional architecture. There are a lot of different avenues you can go into with an architecture degree. And then there's also one aspect that we don't do, which is residential or building homes as well. So that's a whole different avenue. But that's kind of the overview. I think Jeff is going to talk more about the engineering aspects, and then Sina is going to get into Revit, which is our building information modeling that we do all of our construction documents from.
Thanks, Shana. Well, good morning, everyone. My name is Jeff Roman, and I'm our Director of Engineering at Little. And let's see, if I go share screen, this will stop the other person sharing screen. Yes, let's do that.
Will it? Because I can't find mine.
I think it will. Let's see.
Oh, wait.
Did that take over?
It. Yes.
It did.
All right. So, so at Little, we're an architecture and engineering firm. So we do both. There are firms out there that do just architecture, and there are firms out there that do just engineering, but we do both. And there are a lot of benefits to having both of those under one roof. And there's a lot of communication and coordination that happens. There's a lot of teamwork. And it's really important for us to be able to sit down with each other, bounce ideas off of each other, have really quick conversations. And we think it ends up being a much better product. And as you saw from the Charlotte Latin School there, as Shana was showing you, I think what the end product comes out a lot better when you have all those people working together. So let's talk a little bit about engineering. Why did I become an engineer? Well, it was my love of Legos. And this is a picture of me with my Lego city that I had in my parents' basement, sitting on some old ping pong tables. And I used to have them spread all throughout the house. And my parents are like, okay, we need this just to be in one spot and not all over the place. And so before I set up this city, I actually measured all the sets, and I measured the table, and I scaled it down, and I had it on a piece of paper with little pieces of paper of all my sets, and I was moving them around and figuring out how to lay out my city. And my dad said to me, you should be a civil engineer. And I said, well, what does a civil engineer do? And he said, exactly what you're doing. They decide how cities are laid out and how roads are laid out and everything else. And that pretty much started me on a process of investigating what civil engineering was and all that. So hopefully, what I hear a lot from a lot of students that get into engineering, especially things like civil engineering or architecture, a lot of them really enjoyed building with Legos. So, my path, I started out I went to school at Lawrence Tech in Michigan, and I got a bachelor's degree in civil engineering. That's a 4-year degree, and there is a lot of math and science. I had calculus 1, 2, 3, differential equations. I had to take a probability and statistics course. I had chemistry and a chemistry lab, physics 1 and 2, and physics 1 and 2 labs. So it's a lot of math and science, but it's also, as Shana said, it's a lot of problem solving as well. And I started my career in Michigan. And as Shana said, architects are licensed and so are engineers. And in order for an engineer to get a license, you have to work for at least 4 years in the field after you get your degree. And then we have 2 tests that we take. We have one that we tell you to take when you're graduating college, because it's called the fundamentals exam, and it goes over everything you learn in college. So you really want to take that and pass that before you leave college. And then once you get your 4 years of experience, you take another test called the professional engineering test. And if you pass that, you then can become licensed. I moved to Florida and took a new job in Florida. And then while I was down there, I became a small business owner, and I went to the University of Florida and got an MBA degree. So I learned the business side of things. And then I came here to Little to be the director of engineering. And so I actually say that right now I am a people engineer, because I do a lot of managing and a lot of business rather than actually doing the engineering. My background being in civil engineering, the great thing about civil is it's a very broad discipline of engineering. There's a lot of different areas that you can get into, and let's dive into those. So if you're someone who likes math and science and you really like to be outside, if you're an outdoors kind of person, then you might want to think about a degree and a career in surveying and geotechnical engineering, because it's all about how is the land that we're going to build on, what does it look like? What is it comprised of? What are the soil types? If Shana wants to build a multi-story building on a piece of land, is the soil that's already there made for it, or do we have to make improvements to the soil? But everything that we do really starts with surveying. We have to understand the existing conditions of what is out there that we're going to be dealing with. And then when we don't do surveying right, we might end up with a bridge that doesn't line up, which that's not a very good thing. And if we don't look at geotechnicals and our soil samples right, we might have a building that falls over. This is actual picture of a building in China that fell over. And if you look in the background here, you see some water. Chances are maybe some of this soil was really wet and they didn't do their proper analysis and didn't build the right foundation. And unfortunately, the building fell over. That's something we certainly never want to happen. Water resources is all about the treatment of water, clean water. We're here in North Carolina. We've gotten a lot of rain this week. I know some rain gauges here in the Charlotte area, 4 inches, 5 inches of rain. And water resources is all about when all that rain falls from the sky, we've got to collect it. And we need to treat that water, because as it's running across surfaces, it's picking up pollutants, it's picking up sediment. And we want to clean it before we let it go back into our natural streams and rivers, lakes, oceans, and et cetera. So water resources is all about that. On the environmental side, this is a picture of a solar field that I got to work on down in Florida for Florida Gulf Coast University. We actually used the solar field to power the 3 biggest energy using buildings on the campus. Was a great project. I got to be the civil engineer of record. So forever and ever, my name will be associated with this project, which is one of the cool things about doing buildings and engineering and architecture. Environmental engineering, a lot of renewable resources, habitats for protected species. In Florida, we dealt with a lot of wetlands and the importance of wetlands to just the natural cleansing of water and the environment, and how important it is to protect that. So environmental engineers work on that side of things. Where I spent most of my time is in what we call land development. And that is when we have a big piece of property, where do we put everything? Where do we put the roads? Where do we put homes? Where do we put schools? And so I spent a lot of time in my career on that side of civil engineering. And this is actually a large project that I did down in Fort Myers, Florida. It's called the Forum. And we've got down here at the bottom, we've got a shopping center, we've got some apartments and some condominiums, we have some single family homes, some more single family homes, and then along the freeway, this is I-75, we had a lot of office uses, a lot of office buildings that got built there and some hotels. So I got to take part in how are we going to lay out all these roads, where are we going to have the subdivisions, where are we going to have the retail, and all that. And that's something that I found to be really fun. And that just reminded me of, building my Lego city when I was younger. And then we get into architectural engineering and the different components that go into the design of a building. This is a car dealership that we did in Texas. And as you can imagine, everything is always bigger in Texas. And so this car dealership actually had a 2-story showroom right out in front. And as you can see, one of the most important parts about this was making sure those cars are well lit. So people coming in to buy them are really impressed by the cars they're seeing and they want to buy them. So architectural engineering has to do with all the engineering that we do inside of a building. So civil engineers, we do everything as you saw, outside of the building. So we're figuring out roads and playgrounds and sports fields and things like that. But many different types of engineering that goes into the actual building. One of those is mechanical systems. Mechanical systems are all about the movement of either air or water within the building. So you can see here in the upper right, we've got some large ductwork. And some of that is supplying either hot or cold air, depending on the climate. And being this was in South Texas, most of the time, this is going to be air conditioning that's blowing through here. And some of this other ductwork is what we call our return air system. So as we're trying to circulate the air through the building, we're picking up that return air. And then we have on the water side, that's all what we call plumbing. So, when you guys are running a sink or you're taking a shower, you're flushing a toilet, all of that is plumbing. And that's all part of mechanical engineering. And a very important part, making sure we have clean water provided to us and that all the bad water, the wastewater, gets taken away. And then we have the structural engineering side of things, and Sina is one of our structural engineers. And of course, we, in structural engineering, we think of all these iconic buildings. These are obviously two in New York, from the Empire State Building to the new Freedom Tower. But there's structural engineering, and it's just as important in a single-family house as it is in a 100-story building. Because if we don't do the structural engineering right, the building could collapse and people could get hurt. And so, one of the things that the reason why we have licensure as engineers and as architects is because we have to protect the health, safety, and welfare of the public at all times. And so when we are licensed, that is basically saying that we have the training and the education to allow us to do these designs and make sure that no one gets hurt. And that is our number one goal of everything that we do. It's not about how we make the most money, how do we make our client the most money. It has nothing to do with that. It is all about how do we keep the public safe and how do we get them to enjoy the spaces that they're living in. So structural engineering, very important. And then we have electrical engineering. And in electrical engineering, this is all about power distribution, making sure that all your plugs work when you're trying to plug something in. It has to do with lighting. It also has to do with telecommunication, network, Wi-Fi, all these things that sometimes we take for granted, but our ability to communicate over the internet, and how we're having this virtual meeting this morning, it's all electrical and telecom engineers who have made all of that possible. And then another part of electrical engineering that's really important is lighting. And Shana showed you in a lot of the pictures, whether we're using natural lighting or artificial lighting. I showed you one car dealership earlier. This is another car dealership. Lighting is very, very important as well. And when we do site lighting, which is the lighting of the parking lots here, one of the first things that you can notice is that once we get outside of the limits of the property, it gets really dark really quick. And so we have different rules that we have to abide by, that while we want to make sure these cars are well lit in this parking lot, we also don't want what we call light pollution to shine onto the adjacent properties. So if you had a home next to this car dealership, you wouldn't want all these lights shining into your home. So we do things with the light fixtures themselves to make sure that we're not shining light onto adjacent properties. And I spoke earlier about a lot of the collaboration and a lot of teamwork. And this picture you can probably find in any of our offices, probably at any time of the day, is these kinds of meetings that are going on where people are sharing ideas, trying to understand the vision from the client. How do we get the buildings to look and function like they need to? How do we make the engineering systems function like they need to? The architects love to create all these concepts, and then they come to us as the engineers, and we have to figure out how do we actually make them happen. And a lot of times we'll say, oh, that mechanical room isn't big enough to hold the equipment, and we do some negotiating back and forth because they have to get all the classrooms in and all the bathrooms in and laid out correctly. So there's a lot of back and forth and a lot of iterations. And
super glue doesn't hold up buildings.
No. So Shana showed you our design methodology earlier. And if you're familiar with, the scientific method and the scientific process, it's pretty much the same thing. We're generating a hypothesis, our vision of what we think the client wants and what the building needs to be. And then we're going through those iterations. And just like the architects go through iterations, we're going through iterations. One of the most important things that we're doing as engineers is on the sustainability side of things. We want to fine tune our systems so that we use the least amount of energy possible. And so there's a lot of modeling, a lot of mathematical modeling that goes into the different systems that we design. And when you think about it, every light fixture that we add gives off some amount of heat. Every person we put into the building gives off some amount of heat. The amount of glass that we have, the amount of windows that we have allows a certain amount of heat in. Not only does the sunlight come in, but heat comes in. And so we have to do this analysis and try and figure out how much insulation do we put in the walls? Do we put tinting on the windows that allows the light in, but it keeps the heat out? All these different decisions that we make that impact the systems that we design. And so it's a lot of iterations, a lot of modeling, a lot of back and forth before we get into, basically coming up with the actual final design. And as Shana showed you, there's a lot of effort that goes into it, a lot of drawings, a lot of sketches, a lot of renderings and modeling and pictures that we show the client so that they can help see what the final product's going to look like. With that, I think we're gonna turn it over to Sina now, and she's going to open. She's got a Revit model open, and Revit is the main piece of software that we use as engineers and architects to draw these buildings, and they're three-dimensional. So we can see them, we can cut sections through them, we can turn layers on and off, and Sina's going to walk you through all that.
Awesome, thanks Jeff. Well, hi everyone, I'm Sina. Like Jeff mentioned, I'm a part of the structural engineering group at Little. Just want to walk you guys through really quick of the building information modeling that we use at Little. We specifically use this program called Revit. So right now you're looking at an overall view of a 3D view of the architectural model, the structural, mechanical, electrical, and plumbing all linked together. So if we zoom in just a little bit, like Shana mentioned, she was actually speaking of this specific project in her section. This section right here, I believe, is the new model. And Shana, correct me if I'm wrong, but the ones that are surrounding it are the existing. And we have those there just for coordination purposes.
That's correct.
Okay, perfect. So that's one of the great things we get with Revit is we're able to actually model the existing structure as well as the new, just to see how everything's going to fit together and look together as a unit as well. So one of the really cool things we get with Revit is, since everything is kind of formed together, we get to coordinate and see exactly what anyone is working and what they're doing at that one specific time. So any changes that are made, as soon as we sync, which is up here in the left corner, we'll be able to see the changes as soon as possible. I'm going to cut a really quick section through this building for you guys and show the different aspects that it's in the building.
And while that's thinking, one of the things that I didn't mention is time frame. So a school this size, you know, it takes a lot of time, like Jeff was mentioning, and it was probably about a year just designing and coordinating and working things out. And it was, if I remember correctly, it was probably about 15 to 18 months of construction, maybe closer to 2 years. With all the weather we had, but it was a very complicated site, and I've worked on projects. I'm working on a high school right now, and from start to finish, from the time we began designing to the time a student will walk in the school will be about 4 years. So it's not a short process.
Yeah, definitely not at all, especially in a project that's this scale. Obviously, we have different scales in our company that we work with. We have renovation projects. We have buildings that are worth $50 million. I mean, really big projects that we have, and then small scale as well. So we get to experience different projects that we are in. We get to experience different types of buildings. This building specifically, I believe, is steel, but we also have masonry buildings. We have wood. We have concrete. We really work with all different types of things, which is one of the great parts of being an engineer at Little, I would say, in a personal experience, because as structural engineers, we most of the time just get stuck with one specific material or one specific type of structure. Like Jeff was mentioning, a lot of structural engineers, if they're working on a skyscraper kind of project, that's maybe their 5 years of their career is just focusing on that one specific building and designing it and looking at different components of it. Whereas at Little, we get to see a lot of projects from start to finish, and we get to see different components of the building that we work on and different materials as well. So in this section cut, you guys can see the HVAC, the mechanical stuff that are going through. You can see the joist, which is our model, the structural. Just to back up a little bit, this model is actually the structural one. But that's just because I'm in the structural group and I wanted to show you guys that one. However, just because we're in the structural model doesn't mean I can't just click a component of the architectural and see what they actually have in there. For example, this is a basic wall that they've put in. I can just tab and select the floors and see what they have in there, if it's fire rated or what type of floor they have, if it's 3 inches or 4 inches, anything really in a building we can communicate through Revit and just speak to each other that way. I'm going to show you guys another view of just the mechanical. I've left on the foundation kind of just to give you perspective, but there's really different types of views we can look into. And if I want to see just mechanical, I can see just mechanical. If I want to see just plumbing, I can also just see plumbing. This is a really good and easy view to look at, because one of the biggest issues we have coordinating with plumbing is, plumbing going through our footings. Whereas with mechanical, we coordinate a lot about where their equipment is. If they have heavy equipment at the roof, this is what we would use, to coordinate with them. This is just a view of plumbing and mechanical and structural all together. And you can see the mechanical equipment at the roof and what structure is surrounding them. So if you have adequate structure, or if we need to add anything else, this is the way we can communicate.
So Shana, can you take them through, from maybe just put the structural model on and talk about foundations to the difference between foundations and columns and beams?
So the way we start modeling, or the way we start designing a building, is we wait for the architects to give us some direction. So everything really starts with the architects. And like Shana mentioned, architects are basically the tie between all the other engineering aspects as well. So we start looking for some direction from Shana. And once we get some direction, we start designing according to what they really want to have. We get the information as to if it needs to be a steel building, if it needs to be a masonry building. And once we get that information in, we can start designing. And the way we design our columns and our beams is we get how much load that's going to be in that specific surface. For example, at the roof, you would assume there's going to be less live load, which is correct. So our live load, which is essentially anything that moves. So it can be from humans to animals. For example, we are actually in the process of designing a project that includes animals specific in it, and we have to consider how much force an animal would produce on a structure. So a live force would be anything that's alive and can be moving. At the roof, that would be a lot less. So our live load at the roof would be less. And then our dead load is anything that's going to be there essentially forever and is most of the time just self-weight. So
And
the self-weight.
Sorry, Sina, it reminds me of a project, Jeff, that you were showing failures. And there was a building at Tulane University in New Orleans, and they built and designed a library and forgot to take into account the weight of books in the library, which is the dead load. And the building was built and it started to sink because New Orleans is a swamp. And when you start adding a bunch of dead load, and they had to figure out how to solve it because the building was already built at that point.
Yeah, that's great. There's a lot of examples of geotechnical engineering failures, unfortunately. It's really important to coordinate with geotechnical engineers what load is going to be produced through this building down to the foundation. I mean, the most famous example of that, Shana, is the Pisa Tower, of course. Over time, they're trying to fix it, but over time, it's just going to keep sinking. The issue with that is, unfortunately, that coordination is something that has to be established before the building is built. Because no matter what, if the soil was not prepared beforehand, it is very, very difficult to get the soil to be correct strength for the building afterwards, because it's already below the building. So one of those, the coordination between structural engineers and the geotechnical engineers, it is really important. We actually don't have geotechnical engineers at Little because most of the time geotechnical engineers work separate. However, it is important to mention that is a part of civil engineering as well. Geotechnical engineers are the ones that look into the soil and research the soil to make sure how much strength it's going to have, and then report that back to the structural engineers. And we make sure that we size our footings for that correct load or pressure for the soil to be able to support it, essentially. So we get our loads from the roof, we get our loads from the floors, which could be heavier sometimes because there's going to be more people there, obviously, for a live load. And that load initially transloads to these beams. And once the beam transforms the loads down to the columns, it will go all the way down to the foundation where it meets the soil and the soil supports the building itself. So that's really our load path in a summary and a very quick version of it. But there could be different types of analysis. It doesn't necessarily have to be a floor that's supporting a load going through the beam and going through the column. It could be a wall itself that's supporting a soil on its left side or its right side. These are typically called retaining walls, for example, because they're not supporting load that is coming from the top, which we call gravity loads. They're supporting loads that are coming from left and right, which are the lateral loads. Which actually brings me to another really, really big aspect that is sometimes forgotten because it's not really easy to, I guess, communicate through. But lateral loads for our buildings are actually one of the biggest components when we're designing a building. And it's the thing that takes us the most time and the thing that can sometimes really control the size of our columns and the size of our structure. And these lateral loads that I'm speaking of are wind and earthquake loads. These wind and earthquake loads differ depending on the location of, depending on where you are located, obviously. So if you're in Florida, which is a hurricane region, there's going to be really high winds, and seismic is most of the time neglected because it never really controls over wind. But if you're in somewhere like California, seismic always controls, and wind is most of the time neglected because it's never going to be higher than what seismic load is going to be. So that's just an overall look into what the loads are like and how we really size our structure, how we really make sure that it's going to be standing up. And it's just, I just want to make sure that, you know, it's really important that we speak to the architect sometimes, because you can't just automatically know what is the room or the structure going to be used for. It is really important for us to communicate that through with the architects to make sure that we are designing for what it's going to be used for, which is another example of communicating with mechanicals to make sure we get the correct weight from the mechanicals, that we can size the structure correctly as well.
Sina, the other thing, I think that one of the things that was surprising to me, you know, she mentioned wind loads and seismic loads. And obviously when we think about earthquakes, we immediately think about California. But one of the things that was surprising to me was how much seismic design, seismic loads that we have to take into account even here in North Carolina.
That's really true. Actually, we are on a fault. North Carolina has a fault here. So there is occasions where seismic load does control over wind, but North Carolina is one of those locations where you never know. So you actually have to check both. Whereas if you're in Florida, you say, okay, definitely wind is going to control, you know, we don't even have to be concerned with seismic. But yeah, you're right. So if you're in a location like North Carolina, you have to go through the entire design process with both of the cases and make sure whichever one's going to control is the one that you're actually designing for. But so that's an overview of what essentially we do in structural engineering, and just some coordination we do with the architects and other engineering disciplines. But
yeah, so with that, I think Kim and Crystal, if there's a way for us to take questions and answer questions from the students, we wanted to, you know, leave some time for that, see what was on their minds.
I actually have some questions, some from me and then from kids as well. You guys, as each one of you went through your presentations individually, you talked about different soft skills. And I wonder, can you give us just a little bit about specific soft skills that you think are most important? And in your area, how much of your education focused on those soft skills versus the technical skills? And one example I have in mind especially is listening to Shana talk about communicating with a client to render their vision. I am somebody who could never explain to you my vision. I don't have the terminology to do that. How do you work with a client to get their vision on paper when they can't articulate it well? So I guess that's two questions.
So that's a great question, and probably one of the hardest questions is trying to help someone know what they don't know. And so we have a session, a visioning session that we actually do. We'll bring in, for example, if it's a school, we'll bring in administrators, teachers, students even, and we all get in one room and we do an exercise with Post-it notes. And each person will write something that's important to them on this Post-it note, and we put them up on a wall. And it takes maybe 15 minutes. It's not long. And what you'll find is that there are overlaps from different groups on what's important to them. And it could be anything from, safety to I need more storage to I want, a space to feel welcoming. And so they'll start to categorize them into different groups, which is typically very similar to our project type from project to project. Another exercise we do that is probably the most helpful for me is we will put up pictures. We literally go and grab pictures from typically the internet nowadays, We'll print them out, we'll put them up on a wall, and we give clients red dots, green dots, and yellow dots sometimes. And we ask them, we give them again, maybe 10, 15 minutes, and we ask them to put red dots on images that just has a negative feeling for them, or green dots that gets them excited, or things they see that they would love to see in their space. And often what this does is people, if they can't articulate what they like, they know it when they see it. And so if they see it and can react to it, whether it's negative or positive, we go through and we talk about those, and it begins to help us understand what it is they really are looking for. And sometimes it can, depending on the project, it'll take a couple of days. And from that, we'll kind of pull together what we see, because as an architect, you're really focusing on the feeling of a space and the function of a space, because a space can function really well, but if it doesn't have that right feeling, it just won't work. And so that's part of our role, is really being a good listener and trying to pick up on things that people say, body language, all of those cues that that is not really tangible. So, does that answer your question?
Yeah, and I was going to pick up on the soft skills portion. It's something that I'll talk about, especially when I'm presenting to high school seniors, and we're talking about, I'll get a lot of questions about what electives should I take in college, or what extra classes, and communication, and more communication. And then a little dabble of finance too probably doesn't hurt. But I mean, the number one soft skill is the ability to communicate. And as you guys have seen a lot over the last hour, we have to communicate our ideas both verbally and through imagery to our clients. And we have to be able to listen and understand and show empathy towards their situation and what they're trying to accomplish. So number one skill for me is ability to communicate. And so if you have the ability to take a class on how to give a presentation, how to write a cover letter and a resume, just how to give a persuasive presentation where you're trying to convince somebody. We do we in order for us to get work, to get hired, we a lot of times have to go and present our qualifications to a client, and we're essentially doing a persuasive presentation. We're trying to persuade them to hire us. So communication is huge, and having an open mind
and that creative thought process, because which comes, I think, a lot with group projects, people that work well together. Often when we have interns that come into the office, this is my analogy I always use, you can tell which students pretty quickly are used to working in teams and which ones aren't, because there are a lot of kids that might score really high on tests because you give them A plus B and they can give you C. What I like to do is say, okay, well, if I give a student, C and B, can they tell me and figure out what is A? It's that creative thought process of not just kind of regurgitating facts, but how they think and how they approach a problem in a different manner. Sometimes it's taught. A lot of times it's intuitive. The best way to hone that skill is working in groups together, working in teams, project-based learning, essentially.
Those are such great examples. And I have a question. I taught drafting my last year that I worked in my face-to-face school and loved it, but we used SolidWorks. And is there a reason that you chose Revit over SolidWorks?
Well, SolidWorks, from my experience, and it's very limited in SolidWorks, but is geared more towards manufacture type engineering. It's more detailed of gears and building components that go together, whereas Revit has really kind of taken off as more of the larger kind of software that's pulling in a bunch of different attributes of engineering together is my limited understanding of the differences. So I think if you would probably see more SolidWorks if you were in industrial engineering or kind of more component-based building.
I have another question, this time about the technical aspects of the job. For my children, they love their apps, they love their computer programs. Is there a particular app or program that they could use to get some experience with this kind of designing?
It's a great question. So Revit actually is free to download for students if you want to play around with. The other program would be SketchUp. Which is what it says. It's a free program, I think, to download and play around with as well. It's great for getting initial ideas out there. For younger kids, I always say SimCity because it's easy, it's adaptable, and essentially you're planning a city. You're building, you're populating it. It's probably one of the easiest ones. Jeff, can you think of anything other?
Oh yeah, my son is into building buildings in Minecraft.
Minecraft, yeah.
He watches these tutorials, and then he will go in and he has created, and the level of detail, I mean, as basic as Minecraft can be, but they've got all these add-ins and things, and yeah, he has designed some really cool buildings in Minecraft, and you know, that's essentially a 3D program. It's easy to operate and easy to understand, and that, you know, if you've got someone who really enjoys kind of that aspect of Minecraft, of building those structures, and they don't care about all the rest of the game,
Yeah.
that's a pretty good lead into then maybe getting into something like SketchUp, which would be a pretty nice basic program. SolidWorks as well. I mean, as Shana said, though, I do tend to hear SolidWorks being used more on the industrial side. Our industry, the architectural and engineering industry, you know, our predominant standard is using Revit. So there are a number of high schools that I've talked to where they're already starting their students in learning Revit. Most colleges that are teaching courses for our industry are definitely teaching their students how to use Revit.
And I will say I've worked with a high school and taught Revit over the summer to a group of kids that were interested, and ones that were used to building things and programs online already picked Revit up so fast. And so that's why I would think like any of the, like I was saying, SimCity, SketchUp, Rhino is another one. I'm not super familiar with that one, but I hear it's what the young kids are doing. In college, any of those kind of lead naturally. Photoshop for architecture, Photoshop, Illustrator, those are two probably of the biggest design programs used in communicating ideas graphically. Would be other two really good ones. I know a lot of kids use Photoshop already. My 15-year-old knows it. So and most of these have student versions you can download and kind of tinker with.
And a lot of online tutorials as well for free.
Mm-hmm. You can YouTube just about anything.
Well, we're right at our 11 o'clock, so we thank you, Jeff, Shana, and Sienna so much. I don't know if you have anything else you want to ask Crystal or if the students do, but this has been such an engaging and informative presentation, and we'll share it on our iWork Speaker Series page, and I'll send you a link to that. But we thank you so much for sharing your knowledge, and this is just, I've learned so much today, so I thank you so much for sharing this with us, and it's just been a great presentation. So do you have anything you want to add before we sign off?
I just want to say thank you. And again, if you have any questions, I assume send them to you, and we'll be happy to answer any additional questions or follow up.
We really appreciate your team being here. We'll send this archive out to the teachers of relevant courses, and it will be made available on our website. And the Navigator has been awesome in requesting the links as well to post on their website. So I hope that you guys get a lot more engagement from that site based on your experience today. Y'all are fabulous and so very appreciated.
Sure.
Yeah, we've got about a dozen resources listed on the Navigator, and I've helped out I'm trying to remember the acronym, the 5-letter acronym for the Governor's Office on Business Education, but trying to get more involvement from the AE community on that. So I think the only other thing I would add is, if any of the students who watch this are really interested, we can certainly try and do, we've done job shadowing. We've had students, come into our offices. We've got one in Charlotte and one in Durham, and, have them come in for a couple hours and shadow our designers. Now, obviously, we're just about to start weaving our way back into the office given the whole virus situation. So it probably we'd be looking more towards the fall. And if we can do anything virtually, that's, another avenue as well. So we're obviously getting much more, much better at virtual use.
Well, thank you so much for your time and your expertise. And I know our students will find great joy in listening to this and finding out more about these careers, because these real world examples are such a good way for them to learn. So thank you so much, and we'll share this information with you, and you have a good day.
Thank you.
Thank you.
Thank you. Bye.